So what we have here is a character asset that we have used for a game, and Josh is going to show you how the game looks inside of Unity. But this is the Ghost Knight. So the idea behind this was Autodesk asked us to create a really quick game, to help people figure out how LT works and how you can integrate, your assets that you've made in Maya into Unity, so that you can create a video game, which is super exciting stuff. At that point, your creativity is the only limitation, and you can start to do some very fun things. People have done some amazing work in Maya LT. So despite not having all of the tools, you have, again, what you need to create something amazing. So what you see here, if I were to go ahead and just go to the show menu here and hide the curves. So this is the model. Someone has gone in and first made a character concept, right? Which is a series of sketches just to get an idea of what the character should look like. And then at that point, it gets handed off to the modeler, which builds the character in 3D, and then also textures the character. So we have this really cool looking metallic texture, and you can understand what type of material makes up the model just from the texture and the way it's been modeled. So it's really fun stuff. And then if I were to go back to the show menu and show these curves here, these are the control objects. So you'll notice that when I go in and grab a control, as I start to kind of rotate this around, that's how we control the character, right? And then as we start to move this, you'll notice that we have these values here, and this is how we're able to store a pose. So we would go in and pose the character, and then we can go ahead and say, hey, Maya, let's go ahead and save this pose out, because I kind of like it. I don't quite like this pose, but you get the idea. Can do something better. We'll actually get into a way we can create an idle for this, so that'll be pretty fun stuff. But anyway, we have bones that are actually driving this model. Let me go ahead and show you how they look, and they're just like the bones in our bodies, right? So kind of works the same way in 3D. And as you get into rigging, you start to really appreciate like the human body, and it's just so fascinating. But we're not going to talk about that. We'll talk about that later. Come find me later. We'll talk about that. So here we have the character skeleton, right? And again, we can go ahead and, let's say, grab one of these controls to drive the skeleton. You'll notice that if I go ahead and grab this arm control here, we can start to kind of pivot the sword up, and then we can start to have that move and have him roar in victory. Yes! Yes! So that's how we can basically do that. By the way, we won't do that animation. Maybe for another time. But that's how the skeleton works now. We're going to finish out the skeleton by creating a set of leg chains, and then we'll go ahead and look at a few ways we can create controls. So let me go ahead and get started here. I'll just go to the skeleton menu and grab the joint tool. And then from there, I'm going to go ahead and jump to the side view. I'll go ahead and press Shift A so I can focus in on all views. And then I'll go ahead and jump to the side view here. I'll go ahead and press the 6 key so we can view the model's texture. You'll also notice that we can see the wireframe, which is really important. It's important to keep track of your topology when you start to create joints, because if you don't, that joint might end up in the wrong spot, and you'll notice that in your deformations. So if you are rigging an asset, do keep in mind your edge flow. That's what I mean by topology. If you, let's say, had actual legs here, you'd want to look at the edge flow and kind of figure out, all right, according to where my edges are, I need to place a joint here so that the knee will articulate in a very realistic way. And it's very easy to mess that up, so you have to be really careful about that. It's also helpful to study anatomy, right? Get an anatomy book. Figure out where your joints should be placed, because that's how you're really going to start conveying realism in 3D and create something that's really entertaining to watch and play in your game. Games like Uncharted and Arkham Origins. They all have went through this process, believe it or not. I've gone through this process, but I'm going to go ahead and start creating the joints, and I'm thinking about where the knee would be, so we can kind of visualize where the character's knee would be, even though we don't have any legs here. I'm going to show you why I'm going to do that in a second. I'm going to continue this all the way down the foot, and then hit enter, and now we have our joint chain set. Now from there, you'll notice if I were to go ahead and jump back to the perspective view, I just hit spacebar to switch from this viewport here on the side back to the 4-panel view. Now I'll go ahead and mouse over the perspective view, hit spacebar again, and now we're back in the perspective view. But you'll notice that if I were to go ahead and take this chain and kind of move this over, now we can start to have this aligned where it needs to be, right? Once we've done that, it's really important to think about your naming conventions. You don't want to use these generic names because you have to stay organized. Chances are you'll need to access these objects again for weight painting, for adding more systems to your rigs. So make sure to come up with a decent naming convention, something that makes sense. So I'll go ahead and name this first one JNT_L, since it's on the left half of the model. I know it looks like the right side, but this would be the left. You know, you get the idea. So then from there, underscore, and then I'll name that thigh, right? Makes sense. I'm going to copy that, Control-C. We can go ahead and move to the shin and do the same thing. Paste, and just go ahead and label that shin. So you get the idea. We just want to go through and kind of name our joints. And this is really important, especially when we start to weight paint, because we need to tell Maya the joints that we would like to basically re-weight to. So it's just helpful to have a naming convention, and I'll go ahead and show you what I mean in a second. I'll go ahead and name this one, let's say JNTL foot. All right, fantastic. So I won't spend too much time getting that going. Now what I'll do next is I'll go ahead and show you Maya's IK, or inverse kinematic system. Does anyone know what inverse kinematics is? 1, 2. All right, so first I'll go ahead and talk to you about forward kinematics. It's basically rotating down a hierarchy. So you'll notice that we've automatically created a hierarchy here where if I go ahead and grab the thigh here and start to rotate it, you'll notice that the rest of the chain follows. And then when we go ahead and move to the next joint in the hierarchy, so on and so forth. So this is known as forward kinematics. It's great for animating like an arm swing and a walk cycle, but it's not so great when the character needs to kind of jump on the floor and needs to plant its feet. If you try to do that in FK, you're going to be there forever, counter keying, just to make it look right, and at best, your animation is going to look really shaky. Who likes shaky animations? Raise your hands. No one? Oh, she likes shaky animations. Please leave. All right, so yeah, no shaky animations, and she was just joking, I hope. Okay, all right, so back to it. So I'm going to go back to the skeleton menu, and I'm going to grab the IK handle tool, and I'm going to connect from the thigh down to the ankle, and watch this. Now we have this handle here that we can use to simulate realistic leg movements. How cool is that? So eventually we'll be able to skin the foot to kind of follow this behavior, which is super exciting stuff. And I'll go ahead and label this. I'll call this IKL leg. That's fine. And now watch this. So after we've spent the time rigging one half, thankfully we don't have to spend that same amount of time on the opposite side. Maya has a great mirroring tool. It's known as the mirror joint tool. So I can go ahead and grab the top joint in this hierarchy, the root here, which is the thigh, and I can go to the mirror joint tool. I can go to the option box, and then from there, you'll notice I have settings already to kind of choose the plane I'd like to mirror across, and then as well as the type of function I get with the joints that have been mirrored. So this first one here, behavior, as we start to rotate our joints, it's actually going to cause the selected joints to mirror each other on each half of the model, whereas orientation is going to have them move the same direction. So that's basically the difference there. And I could also go ahead and rename my joints to save a lot of time. So watch this. If I were to go ahead and choose mirror, you'll notice now that the right half has automatically been renamed. Everything is good to go. You'll notice the IK handle has been brought over as well. Neat stuff, right? Thank you, Maya. Everyone say thank you. Come on, y'all can speak up. We're here to have fun. Say thank you.
Thank you.
All right, sweet. You're welcome. You're all, yeah, right, like I built this. I'm saying thank you too, trust me. All right, so after we've done this, let me go ahead and show you the skinning process. So we want this foot here to deform with our joints, right? So here's what we can do. We can go ahead and grab the model, and then I'll go ahead and shift select the joints that we would like to skin to, right? And by doing it this way, we're basically telling Maya that we don't want to skin to anything else except for the joints we have selected. So now we can basically come up to this skin menu, and we can choose smooth bind, and then we can go to the option box, and we can be like, oh, all right, that's, whoa, what does that do? Let's pause the video, man. Need to take a quick break so I can figure this out. Just kidding. So Basically, we have settings here to basically kind of initialize the skinning process and tell Maya what type of method we'd like to use for skinning. And it's actually neat because Maya has added a few new skinning options that give us great results. We don't have to use them in this case because the asset that we're using here is really basic. So just go ahead and basically stick with the default settings. The only setting here I actually changed was the top, which is what lets Maya know that I'd only like to skin to these selected joints. Something else that's really important for game characters is the max influence. Like a lot of times for games, you have a max influence, which is the amount of joints that can influence your vertices, right? So with games in the past, that count has been about 3 or 4, because what happens is as you start to increase that, it's going to start affecting your performance. So what you end up with is a character that causes your game to lag. And who likes, a lag in a game? Like, do you? Please leave. So the max influence is also really important. Now with next-gen gaming, it still is around 4. You can probably increase that to about 5 or 6, but 4 is safe, and you can get great results with 4, so we're going to go ahead and leave it at 4. And then this option here, maintain max influence, will make sure that we can only have 4 influences on our skinned mesh. So I'm going to now choose bind skin, and watch this. You'll notice that when I start to rotate this joint here, we're able to now start deforming this shoe, right? How cool is that? And then we can come in and grab the shoe here, the boot, and then we can go to the skin menu and let's say paint skin weights, go to the option box, and then we get to basically use these settings here to tell Maya how each joint should influence the mesh. So right now I have the ankle selected. Again, it's important to establish a solid naming convention for reasons like this. If we just use joint 1 and joint 2, well, how do we know what joint 1 and joint 2 is, right? So make sure to stay organized and rename things. Seems basic, but trust me, it'll save you a lot of time. So I'll go ahead and start to just left click and paint to add influence, right? Because you saw that we got a little bit of sliding when we started to move the toe, right? I don't want any influence in the ankle, so I'm going to paint influence to that ankle bone so that when I start to rotate that foot again, we won't have that problem. So if I were to go ahead and start filling in this area of the foot with about 100% weighting going to the ankle, watch this. Now when we go back and we start to rotate that foot bone again, I'm going to grab that, press the E key to grab the rotate tool. You'll notice that we don't really have the influence now, right, that we saw before. There are a few points there that are being annoying, but you know what? Let them do what they do. But you get the idea. You know how to fix that. And then what's great is that after we have skinned this side, so if I were to go ahead and grab this shoe and skin that, we can basically mirror our weight. So we would grab our source mesh that has been skinned, and then the destination mesh where we'd like to transfer our weights to. And then from there we can go to skin. Please tell me it's an LT. Thank you, Maya. Mirror, skin weights, options. And then again we have settings to choose the mirror plane, what direction we'd like to mirror across. So we're mirroring from positive to negative. How do we know that? Well, take a look at this little X here. You'll notice that we're mirroring in the X direction, right? So with the X being on what would be our right side, this is basically saying that, all right, this is the positive side, so we're mirroring from positive to negative, right? From this side to that side. And I'll go to now choose mirror, and you'll notice that this is going to save us a lot of time because we now have the same results that we have on that boot, right? Whereas before, if I were to go ahead and just undo back before I mirror the weights, take a look at the difference here. You'll notice that we have a lot more influence, right? So again, tools to save you a lot of time. All right, so I'll now go ahead and run the mirror tool again. Fantastic. All right, now from there, we can basically go ahead and create controls. So what I'll do is go ahead and jump to, let's say, create nerves primitives, and I'll go ahead and make a circle. All right, sweet. So what's great about using like a curve, like what we have here across the model is by default, curves don't render, and they're easy to select, so it just works out great. Now, you don't really render in Maya LT, but if you're working in Maya, like the full version, of course you can render in that. So you don't want your control object showing up in your renders, so people are going to be like, what is that floating around? And you'll be like, there's nothing to see here, nothing to see here, doo-doo-doo-doo-doo. And you don't want to do that, because that was embarrassing what I just did. So make sure not to do that. So I'll go ahead and please stop laughing. And then from there, what I'll do is go ahead and snap this over to the bone here on the left side. I'll just go ahead and hold down the V key and middle mouse button drag. And now we have a control there. And then I'll go ahead and press Control D to duplicate it. And then snap that over to the opposite side. And now we have our controls. So from there, we can go ahead and freeze our transforms, which tells Maya that this is now the new neutral position, right? So whenever we need to get back to this neutral pose, all we have to do is go ahead and zero out our transform channels or set the scale to 1. It's really important because a lot of times you need to add more to your rig. And if the rig has been skinned in this pose, if you try to adjust your skinning out of that pose, you'll notice that things aren't going to deform properly. So we have to be really careful about making sure our transforms are frozen. Also, you can see we have some history here that lets us know that we have frozen our transforms, and we also see some history from the NURB circle command that we have run. To create the circle, you want to clean all of that up because it's only going to clutter your scene. You want to work with the cleanest scene possible, otherwise it'll be really annoying. It can start to cause performance issues. Something as minor as this is not going to affect your performance, but as you forget to freeze your transforms, that's when it becomes annoying. Or excuse me, if you forget to delete your history, that's when it becomes annoying. Because you can imagine if you had hundreds of controls, no bueno. So what I'm going to go ahead and do is head over to Edit, Delete by Type History, and you'll notice that all of that information here, any changes that have been made with those input nodes, that has all been baked into these objects essentially, and Maya's gone ahead and cleaned those up. So again, we're staying organized. I'm going to go ahead and name this anim L leg, right? And then I'll go ahead and copy that, go to the right side, and I'll go ahead and name that anim R leg. Sweet. So from there, what we could do if you wanted to is you can actually color code your controls. You can go to the attribute editor. I just press Control A to do that. We can go to Object Display, and then we can move down to Drawing Overrides. You can see I'm using yellow for the right side and light blue for the left. Why would we want to do that? Well, you can imagine if you're working on a complex animation, let's say if he's doing like a cool backflip and then he ends with the 3-point stance, which all heroes end in, right? Eventually that becomes really confusing to keep track of your controls. So this is actually a helpful thing for animators to always remember where their controls are. So if the controls, on the opposite side, let's say something happened and, I don't know, you animate some crazy, whatever you animated that caused the control to be on that side, well, they know that, hey, it actually belongs here. All right, sweet. So I'm going to go ahead and bring that over. I'm going to go ahead and grab the next one, enable overrides, and I'm going to go ahead and bring that over to light blue. There we go. So now we've color-coded these objects. Now it adds clarity, right? What I'm going to do next is go ahead and jump to the outliner, because I'd like to go ahead and basically take these joints here, the leg joints, and I'm going to make sure it's a part of the rest of the skeleton. Really important for games. We need to make sure that our skeleton has a root, right? Otherwise, it's not going to import properly into your game engine. So I'm going to connect these leg joints back to the pelvis here. So to do so, here I have them selected. You'll notice that if I go ahead and shift select the pelvis and press the P key, that's the hotkey to parent. And now when I go ahead and grab the pelvis and I start to kind of rotate, you'll notice that the legs will follow, right? So he's doing a hip dance. Let's go ahead and see how the model looks, because I like to dance and I like to see 3D models dancing. So there you go. All right, fantastic. But you'll see that the controls, they're not really working for us just yet, right? So let's go ahead and constrain our joints here and our IK handles to follow these control objects. So what I'll do is I'll go ahead and grab the control first and then the object to constrain. So I'll go ahead and start with the IK handle, and then I'll head over to the constrain menu and then use the point constraint, which locks down an object's position. So when I do that, you'll now notice that when I grab this control and I start to move it around, the leg follows, right? Cool. And also notice this. When I grab the control and I start to move that, notice how that leg is locked down. Fantastic. And also what's great about constraints is that you can animate that weight. So let's say if you're working with a prop and that character needs to drop their prop at a certain point. You can basically come over here and animate the weight of the constraint, set that to 0. And now you'll notice that when we start to move that control again, well, it already has the constraint, but you'll see that when I start to grab the control and I start to move that, there's no more influence, right? Because the constraint is off. But when I go ahead and set that back to 1, and I start to use the control, now the leg will follow. You'll see that also, since the constraint has been applied, the IK handle is kind of locked down at that point. However, we can switch between IK and FK. Not really going to get too much into that, but let me go ahead and show you what that means. So right now we have this IK blend property that's on our IK handle. If you want to switch to FK, let's say if you want to animate like a flailing leg, and then you want to switch from that to the leg that kind of plants on the floor there, I can go ahead and set the IK blend to 0, and now when I grab this hip control, come on, should work, when I start to rotate, now the leg follows. So you can go ahead and switch between IK and FK. Really exciting stuff, but we don't have too much time here to talk about that, so I'm going to set that to 1. I'll grab the control and set that back to 0 to reset things. All right, sweet. So we've locked down the position of our IK handle. I'll now go ahead and grab the control, grab the ankle. Now watch this. We can head back over to our constraint tool, and this time we're going to go ahead and work with the orient constraint, which locks down an object's rotation. I've maintained offset on. I'll go to now click add, and you'll notice that, watch this, when I grab this hip control and I start to rotate, that leg is not going to move as it did before. Remember how the ankle was reorienting itself based off of the orientation of the hip control? That's not happening anymore. So now we've created a way to plant that foot. So watch this. If I were to go ahead and grab this hip control and I start to use that to kind of move that up and down, you'll notice that the leg is going to stay put unless the IK locks up. And that leads to IK popping, which I hate a lot, because it means that the model looks like it's almost popping when the IK handle gets to its limit. But there are ways around that, and we won't talk about that now, but talk to me after the session, because it's really neat stuff. So what I'm going to go and do is take care of the other side. Basically going to, again, grab the controlling object and then the object to constrain. So right now we're working with the IK handle. I'll go and use the point constraint for that to lock that down. You always want to test things out as well. So after you've constrained, go ahead and move that control and make sure everything's working properly. You don't want any surprises. Can you imagine if you handed your rig off like, hey, it's done, and then they're like, did you double check things? Like, nah, man, I'm the best, right? I don't need to double check anything. And like hardly anything was working. Well then, hey, good luck working at that place again. So what I'll now do is go ahead and constrain the ankle, and there we go. So now when I go ahead and grab the control, take a look at this. When I start to rotate that control, now it's driving the orientation there. Super cool. And then we can do the same thing for the toe. I'm going to show you the final rig by the end of this, but I'm just giving you an idea of how the rigging process works. So now that we've done all of that, we can then go ahead and, again, stay organized. I have a few IK handles that are out of my grouping hierarchy. So what I'd like to do is go ahead and find a home for them. And let's say we go ahead and have them stored in the skeleton group. That's fine. I'm going to press the P key. Now they're stored. I'm going to grab the control objects. You'll notice I have a controls group. And you can create a group by basically grabbing your objects and pressing Control G. So that's almost like a container, but you can transform a group, right? So what that means is whenever someone says transform, it's not transformers. It doesn't like fold into cool, pieces and say Autobots roll out. It doesn't do that. What the transform node does, it allows us to translate, rotate, and scale. All right, so that's what transformations mean in 3D. So that's what we can do with groups. So what I'll do is I'll go ahead and undo that back, pressing the Z key, because I already have a controls group, right? This is really important because by the end of this, you then have this global node that you can connect all of the objects that need to transform. You can connect them all to that global node. So if your character ever needs to be resized, you can do that from here. You'll see that the sword, that's the only prop that hasn't been tied to that global node. Let's see if we have the scale constraint. Nope. But no worries, we could always just go ahead and take the sword and have that parented to, let's say, our global node here. I'm going to just press the P key. So now you'll notice that when I grab the global node, everything scales, right? So super cool stuff, right? If you ever need to resize your model, chances are you may not need to because the size has already been determined, right, by your art director. So it should be good to go. But if you ever need to like animate that for whatever reason, you have a control to do that. And the global control is also important for like kind of figuring out how to animate your cycles that involve, let's say, walking or running. You can basically test out your cycle to make sure that it's working properly by animating this global node. So really neat stuff. All right, so that's basically the rigging process. What I'll now do is go ahead and jump to the final rig that we use for our game. And it's not too different. You'll notice I've added a few more controls here, kind of made it look a little bit cooler, right, than just using a circle. What's great about curves, by the way, is you can actually go in, I just press F8 to go to component mode, and you can start to reshape your curve, creating some cool design. Some people have made some really cool looking controls. Now, really important, your control could look the coolest, but if it doesn't work, you're not going to have work, if you know what I mean. So don't spend too much time designing your controls. Yeah, it's all right to make it look cool, but at the end of the day, it has to be a functional control. Otherwise, like, why are you here? You know. So you can see I've added a control to kind of bend the toe as well. You know, just controls that animators would need. You know, to move the heel, to move the toe. That way we can create a walk cycle and things like that. Or we can have him tap his toe if he needs to eventually dance. You know what I mean? So we have the amount of controls necessary to have the animator just freely bring this asset to life. And speaking of animation, we're ready to talk about that now. So this is and some really fun stuff here. What I'll do is I'll go ahead and take the two arm controls. Just for the sake of time here, I'm going to go ahead and take these two arm controls. I'll then go ahead and grab the center of gravity control at the back, and I'll press the P key. So now when I grab the center of gravity control, you'll notice that when I start to move this up and down, the arms will follow, right? So parenting is basically one of the most basic forms of rigging. Let me go ahead and show you what I did here. I just added those objects to the center of gravity's hierarchy. Cancel. There we go. And then, so here's the center of gravity. Here are our arm controls. I've just added them underneath that parent so that they can follow the transformations of the parent. But let's say we go ahead and animate this guy. So what I'll do is go ahead and think about the pose and try to make this fun, right? The goal is to make this entertaining so that people will want to play your game. If it's not entertaining, well then, why are you making a game, you know? Unless you're a hobbyist and you like to make games that only you like to play, that's fine. It's fine. Yeah, not judging you. No, I'm just kidding. So I'm going to go ahead and think about the silhouette here, just to kind of make it strong and make it fun to animate. You know, we need to kind of break them away from this neutral pose and create something that would be really fun to look at. So what I'm doing here is I'm just kind of thinking about the pose. I'll have him look forward. Have this control here if I ever need to animate his little visor. We can do that. Cool stuff, right? And then what I like to do is I'm starting to pose. I like to actually do the pose myself to kind of figure out what the character should do. If you're going to get into animation, act out. You know, don't be scared. You know, you have to act out your performance. That way you can kind of feel what you need to animate. If you're sitting at your desk like, oh, I think this pose works. Why doesn't it feel like it's working? That's because, honestly, you're being kind of lazy. You got to get up and act out. That's the whole fun part about animation, you know? And even if you have, like, your peers around and you're kind of, embarrassed, don't be, because if they laugh at you and you create a really cool animation, who gets the last laugh? Right? These guys laugh at me all the time, but yeah, who gets the last laugh? When I hit play. No, I'm just kidding. Go ahead and think about your silhouette when you're animating, right? So I'm gonna go ahead and kind of pose the fingers a bit, right? Just so we can create a dynamic silhouette. That way the pose is very clear, right? That's the whole point of figuring out a strong silhouette so that the pose is readable. So what I'm going to go ahead and do is I'm going to grab this leg and I'm going to go ahead and pull this back. I'm also going to go ahead and switch the move tool to local mode, just to kind of move this back a little bit easier, move this forward. So you get the idea. And then we can go ahead and have him kind of arch his back a bit. Right? Cool, huh? In no time at all, right? And then we can go ahead and take his helmet and have him look forward like, I'm ready, right? Much better than what we had before, right? Cool. So once that's done, you then want to lock down this pose. I can't believe I posed it like that quickly. It's awesome. Guess I've done this before. Anyway, here's the cool thing about naming conventions, right? what we can now do is basically a wildcard search to grab all of our controls. You'll notice that when I go ahead and select a control, they all have the same prefix, anim. So watch this. I can come to the top using select by name, and I can go ahead and type in anim _*. The asterisk is how we do a wildcard search in the software, and then 01. If you don't add the 01, let's say if you've created a constraint with your animation control, it might search for that constraint as well. So I like to use the 01 at the end. The 01 does a few things. It allows us to get to just that object, but it also allows us to kind of figure out how unique that object is. So for example, if I were to go ahead and quickly grab this control here and press Control D, now we know that there's a duplicate because of the 02. So something as simple as that can go a long way, right? So I'm going to go back to the top and I'm going to go ahead and search for all of my animation controllers. You'll notice they're all selected now, and we're ready to start creating some animation here. So I'll go to frame 1 and I'll press the S key. Oh, let me go ahead and make sure that solver takes it. Sweet. So that's the set key tool. And really important for cycles, you want to make sure your first and last frames are identical. That helps you to achieve a seamless cycle, right? Because if you don't make sure your first and last frames are identical and you try to create a seamless animation, you're going to notice a little bit of a pop. So if I'm going in and I'm having my character idle, that's how all of my characters idle, right? If you're not careful about your cycles, it's very easy to accidentally create a pop where it's almost like boom, so it's kind of doing this. Not as cool, but you get the idea. So I won't do that again, I promise. I promise I won't do that again. But you get the idea. So we want to make sure that we don't have that, it doesn't look, it's cool. I joke around a lot, far too much. All right, so right now we're animating from 1 to 21. So I'm going to find the midpoint, and that's where I'm going to create a kind of bounce, right, for a center of gravity. So to figure out the midpoint, it's really simple math. We knock off this last frame, so that would be 20, and then we get 10, of course, right? But then we need to think about that last frame again, which is 21, so we just add 1 and we get 11, right? That's basically how you work out your midpoint. I'll now go ahead and make sure auto key is on, and then we can go ahead and grab the center of gravity control, and then with that selected, I'm just going to go ahead and translate him down. So watch this. Since auto key is on, it has automatically created a keyframe for me, right? That's what these fields mean. Like when they turn this pinkish color, that means that a keyframe has been applied. So now watch this. If I were to go ahead and hit play, you'll now see that he's idling. Cool, right? So that's basically the process. Now let me go ahead and add a little bit more realism to this, right? So I'm going to add a few more keys here just to make sure there's follow-through and overlap. Follow-through and overlap, it's one of those important principles of animation. How many people know about the principles of animation? Really? How many people know about the 9 Old Men of Disney? Guys. Frank Thomas, Ollie Johnson, Milk Call? No? Okay, all right, it's all good. Tough crowd, man. Tough crowd. No, just kidding. So anyway, the principles of animation were designed to help the animations reach a level of realism and appeal. Really cool. Disney got all of his greatest animators together and was like, hey, we need to figure out a formula that works that we can use for our films, and that's how the 12 principles were developed, right? So you have these great animators, right? The greatest in the world, right? And they come together and they come up with these 12 principles. One of them is follow through and overlap. And what that means is that when we have a main mass, the appendages connected to that main mass are going to kind of drag behind but eventually catch up. And that's known as follow through and overlap. So let's say, you sir. Yes, you, that's not looking at me. Go ahead, you want to stand up really quick, man? Yeah. All right, sweet. Go ahead and wave your hand. Kind of loosen up a bit, man. All right. How about shake your head? Shake your head. All right, take a look at what's happening to his hair. Keep doing that. I'll tell you when to stop. Isn't that fun? I'll tell you when to stop. Keep going. But you'll notice that as his head moves, his hair is actually following through, right? So his hair eventually catches up to the movement of his head, and that's basically what follow through and overlap is all about, right? And his arms are doing that too. Go ahead and do that again. So now you can see his arms are now following through. Thanks, man. You've been great. All right, this water that I've been drinking is for you. No, I'm just kidding. I wouldn't do that to you. So we can go ahead and do that here with the character here. We can go ahead and, as he starts to kind of move down, naturally with follow through, that means that his head is going to rotate up, right? So watch this. As we start to scrub, you can see as he's moving down, his head is moving up. And then as he starts to move back up again, we can have his head rotate down, right? So now we've created a bit of follow through and overlap. But then we would use the graph editor to clean this up. So let me go ahead and kind of bring this home with the animation side, and then I'll go ahead and get to exporting this out so I don't go over time here. I'll go to the graph editor. The graph editor is going to be your most important friend here for fine-tuning your work, because take a look, we have these curves that we can use to start tweaking our animations. These curves show us how our keys interpolate or transition, right? So you can see that we get this really smooth function curve that lets us know that the animation is going to move smoothly throughout the performance, right? Now, the problem is, if I were to go ahead and hit play, before I start tweaking this curve, you'll notice that there's a pretty nasty pause in the head, right? So that's what I was talking about. That's why we want to make sure we're really studying our cycles and figuring out ways to prevent these weird pauses, right? Because that's not natural at all. Unless you do that, then that's cool. So we can first go to view and turn on infinity, and that's going to show us how our animation extrapolates, meaning how it continues before the first key and after the last key. So watch this. Now I could go to the rotate X. I can go to curves and choose pre-infinity cycle and curves post-infinity cycle, right? So it now went from constant, meaning that there's no cycle, here's constant if you'd like to turn that off, to a cycle animation that continues infinitely. Take a look, that curve will continue. So watch this. I can now go ahead and start to take these start and end keys, go ahead and select them. I'll hold down shift with the move tool selected so I can start to move them. And then I'll middle mouse button drag down just to kind of even this out a bit. And then watch this. When I grab the tangent handles, I'll hold down shift and grab them. And then I middle mouse button click and drag down. Now we've created a very smooth blend. Take a look at that. So watch this. Let's hope this works. Please don't embarrass me. So if I were to go ahead and hide the curves, I like to hide the curves to kind of bring myself into the scene. It's almost like I'm not animating this. I'm just watching this story take place, you know? So now when I hit play, take a look. No longer is that pause there, right? And then watch this. Give me a frame number. Someone say 100. 100? Sounds good. So watch this. No longer are we limited to 21 frames now. This will continue infinitely. You can see how the head is going to continue to rotate, right? Infinitely in time. So what do we need to do now? Well, all we need to do is go to the center of gravity and do the same thing. We'll grab that. It's loaded up in the graph editor. And you can see we don't have to tweak our function curves here. Let me go ahead and show you this. Since we created a really nice midpoint right there on frame 11, you'll notice that when I go ahead and cycle this, it already has a smooth curve. All right, so everything's cool now. Watch this. When I go ahead and start to play the animation, there you go. So now we've created an idle. Yeah, it's kind of rough. You know, eventually we'd want to get to the upper torso and have that kind of move around, and then we'd have to think about the other two axes that would rotate as well, so it feels organic. It feels like a living and breathing life form, right? The trick that I'm starting to figure out more and more with animation is don't think of it like you're animating a 3D model. Think of it more like a story that's taking place right in front of you, and you're just helping to push that story along, you know? That's the fun part about animation. So now, after we've animated the model, what we'd want to do is go ahead and basically bake all of the information into the skeleton, right? So that we can start to hand it off to our game programmer so we can bring it into Unity. So it's time to go ahead and wrap this up. What I'll do is go ahead and first grab the skeleton here. Let me go ahead and show that. And then from there, I'll basically make sure that the root is highlighted. And then with the root selected, we can go ahead and right click and we can choose select hierarchy to grab all joints. So now we've grabbed the entire hierarchy under that root, right? The root's important because it establishes your origin so that when you bring it into something like Unity, Unity knows where the character's center is at all times, right? So that's why this root joint is here. It's not there, because I just wanted to add it. There's a reason. So what I'll now do is go to the edit menu, keys, and I'll choose bake simulation, right? So this is how we can go ahead and plot all of this information out. And I know that the frame range is 21, so I have a few choices. I can set this back to 21, or I can come here and I could say, all right, I want my start and end to be set to 1 and 21. And this is really important because once this is handed off to the programmer, you want to create notes so that they understand your frame range. And you have a few ways of setting up this information. You can animate all of your actions in one file, right? And then you can provide the programmer with just that list of frames that identify each action. Or you can create a separate file that they can use that says, all right, just go to the separate file, and this is where you'll find the attack, or this is where you'll find the run, or the jump. So you get the idea. And we've done this a few ways. So in this last game, we actually created just separate files, but in the game before, we actually made sure all animation was tied to one file. But here's what I'm going to do. I'm going to go to Now Choose Bake. And you'll see that it's going to bake for 21 frames, right? But you can see that the control objects, well, they're still moving, right? Because they're cycling. But I don't need the controls anymore. That information has been baked to the skeleton, right? And I've already double-checked to make sure that the animation does not have any weird pauses or anything like that. So when it's brought into the game, it'll look nice. So all I need to do now is go to like these groups here, and I can start to remove these groups. Let's make sure I don't remove anything I don't want to remove. Let's delete. All right, sweet. So I'm starting to optimize this file so that when I'm ready to hand this file off to the programmer, it's nice and clean for them. All right. So what can we do next? Well, we have, let's say, we don't even need the sword necessarily because a lot of times the programmer is going to add the sword inside of the game engine or the weapon, right? But as a point of reference for an animator, you can keep the prop in there. But honestly, we don't need the prop here. We can go ahead and just kind of remove that. Something else I'd like to point out, just as a tip, as you're animating, if you wanted to, if you're working on a 2D game, you might find this helpful. You can basically go to Panels, grab the orthographic view, and then you can go ahead and create a new ortho camera. So I'll go ahead and create the left view here. Notice that we can also use this to keep track of our silhouette, So if you needed to, again, just as a point of reference, just to kind of check your silhouettes, you can go ahead and use this type of camera just to make sure that all looks well when your animation plays through. So that's just a quick tip, but once you're done with that, you no longer need the camera. Sometimes you can leave it in the file, but I don't need it here. I just wanted to show you that. But either way, once that is done, we're then ready to export all of this information out. So what I'll do is go ahead and grab the model, and then I'll go ahead and grab the skeleton. Here's the root. I'll just go ahead and control-click that. And now we can choose File, Export Selection, go to the option box, save this as FBX, and then we would choose a save and close. The great thing about FBX is that it stores your model, it stores your textures, it stores your joints and animation, right? So everything that the programmer needs for work inside of the game engine, right? So we can now go ahead and choose Export, and I'll go ahead and move over to Scenes and make sure that it gets stored there, or you can go ahead and use any one of these folders here. What's nice about Maya is that once you set up a project, it'll create a list of folders, list of directories, just to kind of help you stay organized. So I might even store this in the data folder, and I'll go ahead and call this Ghost Night. I'm just going to abbreviate that. Ghost Night, and then idle, right? And then if you wanted to, you can take it a step further and add the frame count, so 121, right? Normally that's in a note file, but we can have it stored here. And I'll go ahead and now choose Export. We'll give Maya a quick second. And sometimes you have these warnings, and they basically tell you that there are certain nodes that FBX doesn't understand, but nothing to worry about. Everything works just fine. And you're ready to basically now hand that same FBX file off to the programmer. Let me go ahead and go to Open here, Data. Let me go ahead and go to All Files, and there's that FBX file. So once you hand that off to the programmer, they're ready to do their thing. So just to kind of wrap up, remember when you're creating your joints, keep in mind your topology and also study anatomy just to make sure they're placed in the right spot. Work with inverse kinematics so that you can simulate natural arm and leg movements, right? And remember skinning, really important if you want deformations, right, as we saw here. And remember that there are very helpful skinning tools that you can use to help save time in the skinning process. We haven't really explored other skinning tools that could help us save time. because there are several, and we have them listed out in several of our rigging courses, but I'm not going to get into all of that. Also, remember that when you start to animate, if you want a seamless cycle, make sure to first keep your start and end frames identical, and then you can figure out your midpoints. Once you figure out your midpoints, go ahead and tweak your function curves in the graph editor so that you can start to create polished animation and bring out the realism. This is just a basic example, but can you imagine something like Arkham City, where it's just like Batman's moving all over the place and we don't want Batman to look bad, right? How dare we make Batman look bad, because Batman's awesome. So make sure to keep these in mind. Make sure to think about the 12 principles of animation, tracking your arcs, staging, follow through and overlap, squash and stretch, things like that. And you can look that up, Google it. Google knows all. So just go ahead and Google that and learn more about the 12 principles. It's really fun stuff. But and then to wrap it up, make sure to bake your workout. Go ahead and grab your root, and then just go ahead and use the bake simulation tool or whatever baking tool you have in your 3D software, and boom, you're good to go. And that basically wraps up my discussion. Something else I like to point out is don't forget to save, right? No matter how simple it is to rig your asset, always save, because you might be like, oh, this is simple, I'll get this done in no time at all, and then it crashes and it's like, hey, did I save? And then you have to redo your work, Ain't nobody got time for that. So make sure to go ahead and, I did use that. Make sure to go ahead and save your work, and if you think about all of these things, you'll have a great time, rigging your assets to be brought to life with animation. And once you get into animation, that's when you truly start to create your story and create a mood for the character, which gets super fun.